Questions 19 and 20 both deal with acids and bases, and they're both relatively brief, requiring just that you remember some information. So first of all, the first one, 19, we're looking at an acid-base conjugate pair. That means that they differ only by one hydrogen. So that's my definition here, the thing that I'm working towards, and I just have to reason through that with my four different options. The first one, that differs by two hydrogens. So we've got OH, one negative, has to become, actually, okay, both of these questions deal with acids and bases. That's why we're doing them together, and also because both of them are relatively brief, requiring that you just remember a couple of definitions to apply. So first of all, what is an acid-base conjugate pair? Well, that's something that differs only by one hydrogen. So I'm just going to look through my list here and see what we've got. OH to H3O1 positive, that's a difference of two hydrogens, so that's not my answer. H2SO4 to SO42 negative, that's a difference of two hydrogens. That is not my answer. CH3COOH and H3O1 positive, that has nothing to do with even being related. It's acetic acid and the hydronium ion. That's not my answer. And then this one, CH3, that's a CH3, and H3 versus H2, that's differing only by one hydrogen. D is the correct answer. And then in 20, it's saying that we've got a 1 mole per decimeter cube solution. We're asking which has the highest pH. So we've ruled out of the equation concentration. We've taken care of that. They could have said 10 moles per decimeter cubed. It doesn't matter as long as it stays consistent. Now I can look at the different things. Ammonium chloride, sulfuric acid, sodium chloride, and ammonia are the ones that I am dealing with. So I need to think through, try to remember all of the different things that I know about acids and bases. Ammonium chloride and sodium chloride, both of those are salts. So those are formed from a reaction between an acid and a base, forming salt and water. So that I can rule those out right away. They should be neutral here at the middle at 7. Now I've got sulfuric acid, the names in the giveaway, and then ammonia, which we said was that special one that kind of broke the rules over history of what the previous definition of what being a base was, because ammonia is a base, but it didn't have an OH, it's just NH3. So that was kind of what threw it off and changed our definition of what a base was as a proton acceptor. So with that in mind, we're thinking highest pH, which on the pH scale really means which one is more basic, because we're going from 1 to 7 being neutral all the way up to 14 being a base. We're looking for the most basic, so I can rule out acid right away. That means ammonia is my correct answer.